My name's Lyndsay Prewer. Over the next hour, I'm going to be talking to you about how organizations can improve the resilience of their systems through practicing a type of chaos engineering called chaos days. This is based on experience I've got of leading teams on large platforms running chaos days in a few different organizations. We'll start off by covering a bit about what chaos engineering is and why it's important. And we'll do that with a few different stories. First story is from about 2016, when I was working at a large government organization in the UK. This organization provides services to hundreds of thousands of individuals, businesses, and also third parties that use the APIs that this organization provides to provide services to their own customers. We had recently moved to AWS, which was great. We deployed an API platform that was backed by AWS's Aurora. Aurora is a highly available, highly resilient database service. We had it spread across 2 availability zones. What could go wrong? We were using Aurora to store the configuration data for all of our APIs. So each time a new vendor came and integrated with us, they would set up access to the API and configure it. We also had environments, so we used cookie cutter environments using infrastructure as code to ensure that every environment was the same. So we had a pre-production environment, a production environment, all using the same infrastructure as code. Service was going really, really well, no problems, very resilient. And then to improve resilience further, AWS went from 2 availability zones in our region to 3, which is great. That's an extra availability zone, so even more resilience. That was deployed. Then we decided we'd do an update to our API platform, pushed out our changes through infrastructure as code. All of a sudden, our production database disappeared. And so we thought, what's happened? So we had a quick look and tried to figure out what was going on. And it appeared that when we had coded the infrastructure, we had said, automatically distribute yourself across all of the availability zones and ensure that they're in sync. And what had happened was when the 3rd availability zone popped up, and we did a push for the configuration, Terraform looked at the configuration, compared what we were asking for with what was there, saw this 3rd availability zone that had no database, and thought, well, actually that's what you've asked to be the master, and there has nothing there, so I'm going to take out all your other production databases. And within a second, no production database. But we had backups, right? We had an automated backup strategy that I think put the backups in that same availability zone, which didn't have any backups anymore, so all the others got deleted as well. It took about 3 days to recover from that, and the only way we were able to recover was to take the staging configuration database, which is what our vendors had been setting up on and testing with, and manually porting that into production. That's quite a severe example of how unexpected changes can really catch you out. And no matter how much testing you do, how resilient your systems are, there's always things that are going to go wrong. Fast forward to just over a year ago, probably 2020, around April 2020. I was working at the same organization, this is the 2nd or 3rd time around. And in the UK, the population and businesses were struggling significantly with the impact of coronavirus. Lots of people were out of work, and it was a big burden on companies to keep paying them. The government reacted very quickly and very effectively by setting up various relief schemes. And the same organization, this large public sector organization, built a service very, very quickly. It delivered it early, and that service was accessed by lots and lots and lots of people, millions of people, on its launch day. So its traffic went from nothing to a kind of significant amount, hundreds of millions of requests. No issues whatsoever. They did all of that through their standard engineering processes and practices. And that was a good day. That was a real success story. Third story. with today's cloud technology and smart people like we have in this room and agile and lean practices, you can build planet-scale cool applications like Nest really, really easily. And because you're working in the cloud and working with trusted technology providers like Google, very little can go wrong, surely. So I don't know if any of you have Nest or have experienced this type of issue, but in 2019, there was a network outage in Google's cloud that affected the US East Coast. And that network outage caused Nest to be unavailable, which meant that people that relied on Nest to turn on their air conditioning or activate their smart lock couldn't turn on their air conditioning anymore. They couldn't get into their homes because of some issue thousands of miles away. When I see events like this happen, I'm always interested in the post-incident reports, particularly from organizations that do these kind of reports really well, to understand what the different things that were into play that caused this issue. And this is a classic example of why chaos engineering is so important. Because this issue wasn't just one problem. It was 3 different issues. So two issues that were normally had no impact and benign. And then a new bug. All of those things happened to combine to produce this situation that took out Google's network on the East Coast. Now, there's lots of other examples of this. So Miko talked about a few yesterday. I don't know if anyone you went to Carl's talk on the MAX Airbus accidents. They're all good examples of how things like this can go wrong. And then recently I came across this site, which just shows kind of every month they update this web page to show what outages have happened in the recent month. So severe accidents are kind of happening all the time. Now you're going to watch me struggle to restart my presentation. Just another example of how things can go wrong that you didn't predict. So bear with me a second. Okay, we're back. All these stories are examples of how the systems that we're typically working with today are very, very complex, and they're very hard for us to get our heads around and understand completely all the different ways that things can go wrong, how those, when things go wrong, can contribute to failure. So have a think about the systems that you're currently working with. Think about what are all the component parts? What are the component parts that you work on that you know about? How do those components connect? Are they all working within the same process? Are they in different processes, or are they on different machines? Are they in different third-party providers? Are they in different continents? How are those components connected? How reliable are those connections between them? And what happens when any of those things fail? What happens when multiple things fail at the same time? What happens when you get part failures, so if a connection becomes intermittently available? If you have a really simple system, then that thought process was probably very simple, and chaos engineering is probably not going to be kind of very helpful to you, because your system's so simple that you can easily determine all the different ways it can fail and how that's going to impact your system. Most of us, I think, are probably working on harder systems where you have multiple components, complex interactions and dependencies, often relying on third-party services or components. Chaos engineering helps because it allows us to deliberately introduce failure, And by deliberately introducing failure, we can then see how our complex system responds. And through seeing it respond, we can learn about the different ways it can fail and the different ways it handles unexpected failures. Chaos engineering allows us to put resilience into our systems, improve their resilience from the very outset of their design. And it's very similar to how software engineering has moved towards continuous delivery. When John Osborne first spoke about continuous delivery at, I think it was a Velocity conference several years ago, people thought he was crazy, wanting to release production every day. And the movement to continuous delivery has only been achieved by people thinking about quality from the very outset of when they create things, and think about quality all the way through, and bringing teams together so that you have cross-functional teams working and focusing on quality at the very beginning. And it's the same with improving the resilience. We can improve similar improvements to the resilience of our systems, like we saw with quality through continuous delivery, by thinking about resilience at the very, very beginning, about how when we introduce new capabilities into our systems, how those capabilities will contribute to failure and how they respond to failure. It's also important that whenever we're working with our systems and designing changes, to think about what's going to happen in production with that change. How is it going to respond to the production types of loads, unexpected changes and events? I'm going to use the word resilience quite a lot in this talk, so I think it's useful to cover what I mean. Resilient systems are not those that never fail. Resilient systems are not those that are incredibly robust and would take any kind of failure without going down. Resilient systems are ones that are elastic, that recover quickly. They absorb failure. They might go down, but they recover quickly. They come back up again. Resilient systems isn't not just the software as well. It's also the people and the processes that support that software. A lot of this talk will focus on failure. And it's important to remember that, as in one of the examples I shared, lots of times we're putting systems live and changes live, and they don't cause outages, and our systems keep working despite things failing. And that's happened because we have thought about it or designed resilience into those systems, but also because we have lots of smart engineers looking at those systems, understanding how they're behaving, what adjustments need to be made. And when things are going wrong, they respond quickly and recover. I'm going to briefly cover 4 different types of chaos engineering. Most of my talk will focus on running chaos days, which is a branch of manual chaos engineering. I'll go into more detail on chaos days later, but the idea for running a chaos day came from AWS game days. Has anyone here been to an AWS game day? Okay. So an AWS game day is something run by AWS themselves in one of their kind of centers. And they provide you with a pretend production system and the means to monitor it, and some metrics about how well that system is performing. And it's like a competition. You're divided into teams, and your job is to try and keep this system performing and doing its job as well as you can, despite bits of it failing, going wrong, going slow. And the day gets more and more stressful as they break different parts of it. And it's a fun way of understanding, how do you work as a team to observe a system and to kind of make changes to a system when it doesn't matter if it fails. Chain-specific chaos is where each time your team is making a change to their system, as part of the testing of that change, they try and deliberately break things, fail things. If it's a system that relies on 2 different subsystems communicating, what happens if there's a delay in that communication? What happens when one of those systems stops responding for several minutes, for several hours? Chaos engineering was probably made famous by Netflix's Chaos Monkey. Who's here heard of that? Or is anyone running Chaos Monkey or something similar in their environments? The Chaos Monkey was born out of a problem they had at Netflix, where engineers were building their systems and their services, and those services weren't responding very well when the host went down for any reason, for maintenance or just had an issue that caused the host to shut down. And this was causing lots of problems for Netflix. Now you can ask engineers to try harder and make their services gracefully handle hosts going down, which they were doing. But they realized that another way is to just force the situation and start deliberately shutting down hosts, so that teams got in the practice pretty quick of building their services so that they were aware of a host about to go down and cope with hosts going down unexpectedly. And that one service, the Chaos Monkey service that they built and made open source, has now spread into all sorts of automated ways of inducing failure. So it ranges from taking out instances to also changing network configuration and changing the behavior of networks. A much easier form of automated chaos engineering is if you use something like AWS Spot instances or GCP preemptible VMs. Is anyone here using those? Okay, great, excellent. So for those that don't know what these things mean, so these are instances in these two different clouds that are ephemeral. You can have your service deployed on them, but you can't be guaranteed that host is going to keep running. At some point, that host will need to be shut down, and your service will get notified of that shutdown. But your service needs to be designed to handle it being shut down and make sure you have your service spread across multiple hosts. We ran a hackathon at this organization a few years ago and came up with another way of automating our chaos. So we hooked up a Mario Brothers emulator to a Kubernetes cluster. So every time Mario died, it would take down a pod at random. So there's all sorts of ways that you can kind of automate chaos to help ensure that teams are designing their services to handle unexpected failures. The third form is in-process chaos engineering. This is probably one of the most mature approaches to chaos engineering. And it's where the whole team is thinking throughout the whole engineering process about failure and about resilience. It starts when you're defining a new change or a new capability. As part of defining that capability, you think about the failure modes that capability needs to withstand. You design in kind of resilience, so you design in retry mechanisms or polling or queuing. You think about how you're going to test it. What different experiments do you want to run before you release this to production? This is very similar to approaches that allow us to move to continuous delivery, as well as thinking about quality from the whole outset, involving the whole team in that kind of focus on quality. Involve the whole team in thinking about failure and resilience. So there is a fourth, and the fourth chaos engineering is something you might all be doing already without realizing it. And that's unplanned chaos. So who here has had a production incident in the last year? Great, excellent. So you're all probably learning quite a lot about chaos engineering already. And production incidents, whilst they can be a bit stressful, they are fantastic ways to learn. They're basically unplanned, kind of free opportunities to improve the resilience of your system. To do that, though, it's important to get in the habit of treating production instances as learning opportunities. It's important to keep looking at how can you improve, firstly, the way your teams handle incidents. So what are the ways they communicate? How do they can document what they're doing? How do they kind of respond? What are the different bits of logging or dashboards that they're looking at? Then try and also improve how you do post-incident reviews, because that's where a lot of the lessons from an incident come out and benefit not just the team as they're talking about how did they notice where the problem is? What things did they try to do to fix it? What things did they not try to do to fix it? And by discussing how the team responded, what knowledge is in different people's heads, spreading that knowledge is one of the most effective ways of improving the resilience of your team and their systems. Often when people run post-incident reviews or postmortems, they will say, we need more logging, we need more alerting, and we must update our runbook. Those things pretty much always come out, but having a big list of improvements like that is not where you get most of the benefit, because generally no same incident kind of happens kind of frequently. They're generally fairly different. Instead, the learning that comes out is when people that are unfamiliar with the system are starting to learn how others more familiar diagnose and monitor kind of issues. They learn about how it might fail in unexpected ways, so that when they're working with it in the future, they can respond more quickly, or when they're designing improvements to it, they can incorporate those kind of failure mechanisms. When these slides go out, there's some links to kind of suggestions on how to run better post-incident reviews on this slide, so I highly recommend having a read of those. Chaos engineering helps in quite a few different areas. As some of the talks here have already talked about, it's not just code that we're focusing on here. I know most of us here are probably engineers. Making code better, making code more resilient is fairly simple, to be honest. Most of the challenge that we have in software engineering is people and communication, managing complexity, and managing our processes. Chaos engineering helps us, firstly, give people more knowledge about how their systems fail. What types of failure modes do they need to consider? What are the ways that they can respond in incidents? How should they change the way they write tests or write systems to ensure they're more resilient? How do their own systems work? How do they know if their own system is about to fail? It helps improve your processes so that when an incident does happen, it has less impact or no noticeable impact. It helps your teams get the most from kind of learning about an incident after it's happened. And it also can inform your engineering approach so that as you're designing changes, you start thinking more about resilience. Having provided those improvements in those areas, then it's useful to consider what can you do to your product to make it more resilient. Imiko's talk yesterday said about how complexity was the enemy of security. And the same goes for kind of resilience. The harder a system is to reason about and to kind of picture it and understand, so the harder it is to fix when there's a production issue. So when teams are looking at failures and how they can improve the resilience of their system, making their system much easier to reason about and much simpler is a huge important thing to do. Secondly, observability. And what I mean by this is, how can you tell what your system is doing? How can you make it very easy to see any leading indicators that might indicate a kind of a problem? I'm currently working in logistics, helping an organization automate parts of their warehouse. And in the warehouse, we have this huge, massive sorter where you put boxes on one end and they go through all these conveyors and get routed to 10 different trucks at the other end. And the kind of failures we have there are where boxes don't make it to any truck. Instead, they go to a special area, which is badly named jackpot, which is, in most situations, is a really good thing, but when you get lots of boxes going to jackpot, that's a really bad thing. And the observability of this system is terrible. When a box comes to jackpot, although there's a transaction history of all the different things that happen to that box, it can take me half an hour of investigating what happened to that box, what happened to the truck that it was supposed to go onto, what happened to the label that went in that box, to figure out, why did this box not make it onto the truck? So observability is a really important thing to consider when you're designing these systems. And then finally, runbooks. When you're putting any change in, how is the future you going to know how to monitor it, how to respond when things go wrong? Right, let's move on to the main topic then, chaos days. How do you know when it's right to run one, and how do you do it? So the first time we ran a chaos day was a few years ago at this, again, a public sector organization. And it's a very, very large organization. It provides services to hundreds of millions of individuals and businesses. There's over 1,000 microservices running on this platform. And they have, probably, 60 odd teams. And these teams are fairly decoupled. They're all working on public-facing transactional services. But underpinning all of these services is a platform. And I was leading the 6 teams that built this platform. So we had teams that specialized in the logging metrics and alerting systems, teams that focused on the build and deployment parts of the system, teams that focused on the managing the infrastructure or the database or the instances. As you can see by the numbers, we had a lot of traffic going up through this system, and this traffic was very spiky. So for instance, when we launched the coronavirus relief services, our service got hit by 100 million requests within an hour. Our busiest day, which is, before coronavirus, was at the end of January, when most people in the UK do their tax return. That traffic goes up exponentially to these kind of levels. And for our team, it wasn't just important to ensure that the underlying platform supported all of this front-end traffic, because remember, our teams were supporting 60 delivery teams that each owned these services. These 60 delivery teams were responsible for checking these services were working correctly and dealing with any problems that happened. So those teams relied on all of the logging and metrics and alerting that our platform produced. And as you can see by these numbers, the amount of log messages our platform producing was just insane. So even if things were working okay on the front end, if we had an outage in our logging infrastructure, that was still a really bad thing. We started building this platform around 2013. We're using lots of cool tech back then, but AWS wasn't available in the UK, so we're using a few other different cloud providers. We went from 2 teams to 10 teams really, really quickly. That was not a time to do chaos engineering, because it was frantic. We were learning a lot about the kind of platforms that we were working with, very focused on getting things delivered with a kind of fairly small amount of users as well at that stage. As the number of services and the number of transactions grew, so we realized the need to be spread across 2 different cloud providers. Again, AWS is still not available, so we're using some other third parties in the UK. There was lots of pain doing that. I recommend running active-active, wherever you can, but not across 2 different cloud providers, particularly ones that are fairly unreliable. So we had lots of unplanned chaos, and we got really good at responding to incidents and learning from incidents, because our systems would go up and down quite a lot. Then finally, a few different things happened in 2017. AWS became available to us in the UK. And the other big thing was that our production or development teams were given the ability to deploy to production themselves. Up to that point, they could deploy to every single pre-production environment, but to get to production, they had to put in a ticket with our infrastructure team, and that infrastructure team had to take a package to deploy to production, put it onto a USB stick, walk it across the room, plug it into the other kind of production environment and do the deployment. So the combination of AWS self-service deploys meant we were in a really good place. And we saw a really big improvement in the resilience of our systems, the performance of our systems. And then we realized, okay, let's try out how resilient our systems are. And we had this idea, must have been around October, November, that it'd be a good time to run a chaos day, to actually deliberately try and fail some of our systems. And this was because our busiest day was at the end of January, so we had a couple of months to kind of just work out what could go wrong. So how do you run a chaos day? So firstly, you need to gather together the right people. And we called them the agents of chaos. In your organization, think about when something goes wrong in production, who do you go to? Who's the person that you drag in front of a computer and say, there's something wrong, help fix it? And they generally can fix it really, really quickly. That person is the person you want in this team, because they know the system really, really well. They're the person that you don't want ever to be hit by a bus, or don't want to ever let go on holiday when there's likely to be a production issue. So when you're running your chaos day, you simulate this person being hit by a bus, not too realistically, but you make them unavailable to the team. And you also allow that person to design the experiments and come up with interesting ways that they want to learn about in terms of how the system could fail. We had 6 platform teams, so we took the expert from each of those platform teams and kind of put them together in a room to figure out what they would do. Now, I've said that this should be a closed team. we chose to make it, to have their planning done in secret because we wanted the element of surprise, wanted people just to not know what was going to happen. Now, further reading I've done this since kind of running these chaos days, I think there is benefit in having open teams, because when people are planning what experiments they're going to run, there's still a lot of learning that you get from that discussion. As if different experts are thinking about, what don't they understand about how their systems could fail. People that are unfamiliar with the system, they learn a lot through being exposed to those conversations. So you can go closed or open, and there's benefits in both ways. The next step is to get that team, or everyone involved, to map out their system. So do a rough architecture diagram that shows what are the main components that your teams own, how are those components connected, what's the rough steady state traffic that's hitting those services, and also what's the kind of internal traffic, so internal requests, log messages, alerts, that kind of thing. Which parts of the system don't you own, can't you control, and if they fail, you can't really do anything. Which parts of your system should you really, really, really not fail, even if you're just doing this in a test environment? Because, for instance, if you're doing some testing and you cause something to fail and that slows down some other delivery teams, then that could be quite a problem. So having mapped that system out, lock these experts in a room and ask them to brainstorm. Just trust them to come up with lots of different experiments to run on how something could fail and what they want to learn by it. When Apollo 13 had its kind of significant problem with, I think, oxygen, I don't think it would have been managers that got together in a room and figured it out. I suspect it was the engineers that were just asked to figure this out. And it's the same with the platform team. I got all the experts together, we gave them the constraints, gave them the goal, and then just see what they came up with. And generally, your teams will come up with 20 to 30 different experiments, and you then need to help them prioritize them. So what are the experiments that we most want to kind of learn about? What things are we worried about happening next week, next month, that we really want to simulate? Then put a bit more structure around those top 10 experiments. Describe what is the component that you're going to fail, and what are you expecting to happen? What's your current hypothesis about what will happen in that failure mode? How are you going to invoke that failure mode? And very importantly, if the team doesn't figure it out and doesn't manage to kind of recover, how are you going to roll back that failure and get your system working again? The first time we ran our chaos day, I think it took about 2 or 3 days to restore the environment to its kind of normal health, and we weren't terribly popular because of that. One of the other things we learned from our chaos days was how different parts of chaos can interplay really well. So you can run different experiments together to see, okay, what happens if you take out your databases and also you can slow your network down or slow down the alerts. But we did find that if you take out all of your logging, alerting, and monitoring, then there's little point in running any other experiments because your teams just become blind to anything that else is happening. Running a chaos day is a great opportunity to also think about InfoSec. So how can you test out the security of your system, the security of your teams and their processes by trying to simulate hacking attempts at the same time? And this was something that we had lots of fun doing, that when we were running the Chaos Day, we set up a fake user in Slack who was impersonating one of the other engineers and started having this user ask for what seems to be legitimate requests for access to different systems and say, oh, the system needs turning off. And it took a while for people to look at the user, look at the name and the kind of avatar and think, well, I don't think that is really that person. So it's a great opportunity to combine simulating failures with simulating attacks. Then you need to decide where you're going to run these experiments. A lot of people think that because Netflix run all their experiments in production, it has to be production. It doesn't have to be production. There's lots of things you can learn by running chaos experiments in other environments. What's important is that the environment you're running it in is as similar to production as possible. And that means you want to have load going through that environment that is going to be like what those components would see in production, or enough load that they would trigger the kind of behavior that you're wanting to see when something fails. It's also really important that you've got similar or the same kind of telemetry. So you want to be able to see exactly the kind of logs and alerts that you get from your test environment as you would in production. And this might take some reconfiguration. So for instance, we had, as cookie cutter environments, including all of our telemetry, we didn't have alerts always going off in our pre-production environments because that would just kind of annoy the hell out of teams. But we had it configured so we could turn them on and off. And if you wanted to have alerts coming out of your pre-production environment, you could do. So when we ran the chaos day, we turned alerting on in our staging environment. You also need to consider are there any parts of this environment that you shouldn't touch? And this is where it is important to have some consultation with other people that rely on this platform, this environment. If they've got a critical release they're trying to get done in that period, then it's important not to kind of hamper that. Finally, decide on how you're going to communicate. So if you have a production incident, it's a good idea to have a set way of communicating, both internally in the team that's working on resolving that issue and also communicating out to stakeholders. When you run a chaos day, you want to simulate that as accurately as possible. So what communication channels should teams be using when they're responding, and what should they use to respond to communicate with any stakeholders? Then the day itself. You have to decide how much warning you're going to give teams. So when we first kind of ran the chaos day, we told people, we said, we are going to be breaking stuff on this day, but please, if anything goes wrong, just pretend it's an ordinary day. You don't want developers stopping work that day and just watching all of their dashboards thinking, I know something's going to go wrong, just where's it going to go wrong? You want people to be busy working just like you would if a production incident occurred. You need to consider are there any significant releases going on, just in case you need to kind of choose a date that's kind of far away or after those. Very important to decide when you're going to stop breaking things. If you're running just a single chaos day, I'd recommend stop breaking things a couple of hours before the end of the day, because those plans you had for how you'd roll things back, sometimes they don't quite work out and you have to come up with new ideas. Then get the agents of chaos in a room or a kind of virtual room together. It helps if you have someone facilitating their activities, because they can get quite carried away in terms of breaking things and letting like one particular failure just go on and on and on and cause more and more pain for the teams that are trying to respond. The aim of this day is not to inflict the maximum pain on the teams, it's to learn. So you want to, if you've got 10 experiments, you want to try and get through a good proportion of those across the day. So time box how long you run experiments for. If the teams haven't figured out what's going wrong after, I don't know, half an hour, roll it back and move on to the next one. Chaos days are a great way to practice how you respond to incidents in terms of the documenting or creating a self-documenting timeline, which aids then the post-mortem or retrospective that you do at the end. We use Slack in this organization, and helping people develop the discipline to, even if they're having conversations, to put the right kind of message into Slack that shares what they discussed, what they look at, what they're about to do. It just makes the review process really easy. For everyone else that's responding to the chaos, they should just be working like it's just another regular day at work. They also need to be treating, if these experiments aren't being run in production, they need to be treating any problems they see in the chosen environment as though it were production. So imagine that production is on fire, and just work in a way as they would for a production incident. Having run the chaos day, the next really important bit is to kind of do a review and figure out what can we learn from it. And when you're doing this on large platforms, if you've got multiple teams, then ask each of those teams to run their own retrospective. Ask them to think about these different areas. So, what worked well and didn't work well from a people perspective, process perspective. What do we see in our products, in our tech stack that didn't work so well or worked really well? So have each team run that retrospective. Focus on on the kind of the process and the people kind of improvements before just thinking about how can we code this better. And then get one person from each of those teams to come together and do a team of Teams Retro where they take their top 3 or 4 learnings and share them. And this worked really well if you have an organization where you have loosely coupled teams that own part of the stack, because a lot of the learnings they can come up with will be specific to their part of the stack. So that having the team-specific retros is a great way of sharing. But there's also things that will cut across different component teams. So it's important to share those as well. We've probably run about 5 different chaos days at this organization, and so part of our review process was to think, what would we do differently next time? How are we going to make this even better, get more lessons out of the next one? So one of the improvements we made was, instead of having a chaos day, we'll have a chaos week. It doesn't mean we're just doing chaos day 5 days of the week. It means that we're going to run experiments more spread out and like a slower pace, and which means there's more surprise, and people can't just stop work for a week and wait for something to happen. They have to keep working, and that was a kind of really useful thing to do. If you've not done chaos days before, I recommend starting really, really small because there's a lot to learn, a lot that you can get wrong, and you learn a lot from just doing a very, very small number of experiments, maybe 3 to 7. Limit the scope of your experiments. So don't just go for kind of small things, small tweaks on areas that you don't really understand or you can't predict how it's going to fail. Don't worry about not running these in production. If you have a way of running in production safely, the way you can prevent impact on your business, then that's really good. For places like Netflix and Amazon, they've had to invest a massive amount on how their components are architected, how the components communicate to allow them to run these experiments in production. And so there's a significant investment if you want to get there. A bit like the kind of how you can benefit from production instances, the same with chaos days. You should use them to learn about the system. Chaos days aren't designed to come up with a big to-do list of all the different things we need to fix in our systems, because a lot of your engineers will know that you've got technical debt, and they'll know that different bits will fail. It's instead trying to spread the knowledge of how do you observe failure, how do we better respond to it? And then finally, enjoy it. It's lots of fun for the people breaking things. It's less fun for the people responding, but I think when you get them together, they kind of all forgive each other and really enjoy it at the end. So I hope this talk has been useful to you. I'd really encourage you to go away and think about your own system. Think about where you're at in your journey with resilience. What could you do with your system to help improve its resilience? Do you just have enough unplanned chaos that you can think about how do we respond to production issues better? How can we learn more from our own production issues? Or is it time for you to actually start designing some experiments, maybe for the next change that you're putting into production? How can you simulate failure and learn unexpected ways that change might cause failure? We've written about this in an open source playbook. There's a link on the slide. We've got also lots of other playbooks around this platform that are described in building digital platforms. So I encourage you to check those out if you're interested. Thank you very much for listening. If you've got any questions, we have 15 minutes.
You mentioned the slides being available later.
Yeah.
Do you know anything more where?
No, I don't. I'm expecting NDC will ask me for the slides and they'll publish them. So I'll put a link to them and tweet them though as well. What other questions are there? Marcel?
I've got a question. How do you convince your senior leadership to get permission to do that kind of stuff?
Great question. So the question there was, how do you convince senior leaders to give you permission to do something like this? I think being clear on the benefits and the low risk, or the fact that it's safe to fail. It's particularly easy to sell if there is a significant peak event coming up or a significant impact that your senior stakeholders are worried about. So, and if you're working in kind of retail, then the Cyber 5 kind of period, so kind of Black Friday and Cyber Monday, you get a lot of traffic in that period. And so if you have an organization that is worried about how the systems are going to handle that traffic, then running a chaos day several months beforehand is quite an easy sell, because it's providing extra confidence, and it's not a big cost as well. We took 7 people out of the team for probably a total of 2 days when we ran our first chaos day, and you learn so much, and that learning is really significant, positive investment in your kind of platform. Senior stakeholders hate it when there's a production incident as well, because you get all sorts of awkward questions being asked, which can be very hard to answer. So anything that you can do for them that's going to say, well, it's going to make production incidents less frequent, and we'll be able to handle them better, is a good thing. What else would people like to know or ask? Okay, well, I'll be around for the rest of today and tomorrow, so if you have any further questions, come chat, and thank you very much for listening.